Hello everyone, today I'm going through some questions about special relativity, about length contraction and time dilation. So first we go through some definition. The length of an object measured in its rest frame is called its proper length, and we usually show it with L note. L. The length of that object, as measured from an inertial frame of reference in relative motion, parallel to that length, are always less. And so we name it contracted length, and we show it with LV. So what's the relationship between LV and L naught? Just simply you can say LV equal L naught times minus V2 C2. Okay, and because this part is always smaller than 1, so as a result LV is always smaller than L naught. And also we have time, relative time, but we have time dilation. So the time taken for an event to happen in its own rest frame is called the proper time, and we show it with just T naught. And the time taken for that event, as measured from an inertial frame of reference in relative motion to the first frame of reference, are always greater. Because of that, we say we have time dilation. And because we have time dilation, and we know this part is smaller than 1, so definitely for time TV to be larger than T naught, something that we need to do, we need to divide T naught by 1 is V2 C2. Okay, right now we go through some questions to deepen the understanding. So as you can see in the question, we have a box on a train. So just I draw, this is, let's say this is our train, and let's say with my drawing, that's terrible. And this is a box inside, and our box in all dimension is 70 centimeter. Okay, we have width, we have height, and we have length, all 70 centimeter. And then the train starts traveling at a speed of 0.5 c. So very fast train. It's, let's say, moving at this direction, 0.5 c. What are the height and width of? So they are asking about height, and they are asking about width as measured by passenger. Okay, so we have passenger on the train and a person on the platform. Okay, so firstly we talk about height. So as the moving object shorten in the direction of motion, we know that just the object shorten at the direction of motion, not other dimensions. So the only dimension that might change is the width. So it means height and length are measured 70 centimeter from both frame of reference. So about height, so we know height anyway, regardless that which frame of reference you are in, is 70 centimeter, because height is not at the direction, motion is this direction, height is this direction, so they're not at same direction. The same story is about length. So length also stays the same, but the only thing that might change is the width, because as you can see, width is parallel to direction of motion. Okay. So right now let's talk about width as can be seen by the passenger and also as can be seen by the person on the platform. But as the box and the passenger are at the same frame of reference, so there is no relative motion between them. They are moving together. So relative motion between passenger and box is 0. As a result, the passenger measures the proper or rest width, which is 70 centimeters. Okay, so I can say width as measured by the passenger is 70 centimeters. Width as measured by the passenger equals 70 centimeters. But what about the person on the platform? There's a relative motion between the width of the box and the person on the platform. So the person actually measures LV. So it means the person measures the length a little bit, sorry, the width a little bit shorter. So 70 centimeters is our L naught. And right now we want to calculate our LV. The only thing that we need to do, put this in the formula. So I write this one, that is our L naught. Then just the only thing that I need to do, write the formula. That is L naught 1 minus V2 C2. And just substituting number, that this one is 70 centimeters, so I convert it to meter, that is 0.7 bracket 1 minus then 0. I don't need to just substitute C, just I put a C as C, and I can just simplify that with C in the denominator. C squared divided by C squared bracket. So as a result, it is equal to, just I write it here, 0.7 1 minus 0.25, and if you put it in your calculator, is equal to 0.61 meter, or we can say simply 61 centimeter. So as you see, the width as seen by the person on the platform is shorter than the width as seen by the passenger on the train. Okay, let's go through another example. This one is a train, again, is traveling at a speed of 0.5 c. Okay, a passenger drop a ball from a height of 1 meter. So again, we have this train, and there is someone here dropping a ball, just dropping a ball. This is our ball from the height of 1 meter. And the train traveling at a speed of 0.5 c. Okay, what's the time for the ball, okay, to hit the floor? So we want to see time of travel from here to the floor of the train as measured by the passenger, okay, and a person on the platform. Okay, again, you see the event is dropping a ball. Okay, and there is no relative motion between the passenger and the event. It means event dropping the ball and passenger, they are at the same frame of reference. Okay, as a result, the passenger measures proper time or T naught. So just we need to calculate our T naught, and how we can do it, the way that always we calculate the time that a ball, if you drop a ball, how you calculate the time it takes to hit the ground. So I say because we drop that, so it means U equals 0, and I want to say downward as my positive direction. So just I use the formula S equal UT plus half AT squared. That A here is equal G. I consider that G equal 9.8 meter per second squared. And because u is 0, so this part is equal 0. So s, and s we know is 1 meter. So half, and because I said downward as positive, so it's 9.8 t squared. So as a result, t squared equal 2 divided by 9.8. So t is equal actually 0.545 second, and this one is t naught because it's measured by this person on the train, and the event is also on the train. So this is proper time right now. And a person on the, right now I want to measure, calculate this time as measured by the person on the platform. Person on the platform and the event that is dropping the ball, they are in relative motion. So it means something that person, because it's in relative motion to the event. So something that this person measures or is TV. So I have my T note, I want to find my TV. Just the only thing that I need to do, put it in the, writing the formula, and then substituting number, that is TV equal, and T note just we calculate 0.45, and then 1 minus, again same, 0.5, say square C2, this is V2, and divide by C2. Simplifying this by this is equal 0.45 divided by 1 minus 0.25, so equal to 75. As a result, TV is equal 0.52 second. As you can see, the time is dilated. Here was 0.45 second, and here 0.52 second.